Welcome to the Controller Pilot Data Link Communication, or Cpdlc, lesson. This lesson will provide an overview of the Cpdlc program and will include examples for both Boeing and Airbus equipment. The Flight Deck Procedure section will include highlights of common operations using the Boeing 737NG aircraft. In the first part of this lesson, we will discuss the Departure Clearance Service, which is referred to as DCL. The latter part of the lesson will cover Cpdlc Enroute procedures. The application provides a means of communication between the controller and pilot using data link for ATC communication. They include a set of clearance, flight information, and request messages. As frequencies are becoming increasingly congested, the use of data communications to supplement the routine voice communications will increase efficiency, capacity, and safety. The FAA's Next Generation or NextGen Air Transportation Project is a compilation of programs designed to improve and modernize the National Air Traffic Control or ATC system. Some programs already being implemented include the Automatic Dependent Surveillance Broadcast, or ADSB, the Collaborative Air Traffic Management Technology, or CATMT, and Data Communications, or Datacom. NextGen will be delivered and implemented in phases. Part of the first phase involved a partnership with industry that focused on three main priorities: improved separation standards for heavy aircraft, better coordination of traffic on airport surfaces, and streamlined departure clearance system using Datacom. Some tangible benefits already experienced include lower fuel burn, reduced carbon emissions, and improved on-time departures and arrivals. The Data Communications or Datacom program is critical to the success of NextGen. Datacom services provide digital communications between pilots and ATC, as well as enhanced air traffic control information to airline operations centers. Datacom directly links ground automation with flight deck avionics for ATC clearances, instructions, traffic flow management, flight crew requests, and reports. The FAA has already deployed Datacom in the oceanic airspace using Future Air Navigation Services, or FANS, avionics. The FANS program was implemented as a result of ICAO's concern about the aging infrastructure of the navigation management system. FANS includes Automatic Dependent Surveillance Contract, or ADSC, and Controller Pilot Data Link Communication, or Cpdlc. A generic FANS installation includes a Multifunction Control Display Unit, or MCDU, a data link system, and SATCOM. DCL provides automated assistance for requesting and delivering initial and revised departure clearances. DCL provides messages for the following: the flight plan route, initial and requested altitude, beacon code assignment, and departure frequency. Messages will be selected from those already used in FANS-equipped aircraft. DCL is designed for use in surface operations and replaces the existing pre-departure clearance, or PDC, procedures. On Datacom-enabled planes, the controller sends digital route information directly to the aircraft's Datacom receiver. The pilot reads the instructions on the screen and either accepts or rejects. Once accepted, the instructions can be loaded directly to the aircraft's onboard computer system. The DCL process takes only seconds to complete. Just as in current operations, dispatch will file an ATC flight plan with the Enroute Traffic Control Center, or ARTCC. ATC Automation creates a proposed DCL and presents it to the controller for review. The controller may modify the DCL with local data, such as a departure procedure, then approves or revises it. Upon delivery of the DCL to the aircraft, the automation system forwards a copy to dispatch as well. The flight crew activates the data link system by logging on to the ATC system using ATS Facilities Notifications, or AFN. ATC can accept valid logon data before the controller reviews the DCL for approval. When the controller reviews and approves the DCL, ATC accepts the logon and initiates a Cpdlc connection between the aircraft and ATC. ATC transmits a controller-approved DCL to the aircraft via the Cpdlc connection. If changes in tower conditions occur for weather or other reasons, ATC will amend the clearance information and transmit a revised DCL to the flight crew. Typical pilot roles include: the pilot monitoring manages the communication with ATC, and the pilot flying will verify the information and execute. Boeing aircraft and Airbus aircraft differ slightly in their Cpdlc indications. On Boeing aircraft, there will be an ICAS advisory message along with an audible tone in the flight deck to indicate a message from ATC is available for viewing. On Airbus aircraft, the ATC message push button on the glare shield illuminates, along with an audible tone in the flight deck to indicate a message from ATC is available for viewing. There are three common responses to an ATC message: accept, reject, or standby. Standby can be used by either ATC or the flight crew if there will be a short delay in the response time needed. The Cpdlc ATC log contains the archived messages that can be reviewed. The most recent message appears at the top. Older messages will be deleted once the log is full. Typically, the message log is cleared out automatically after each flight. Logon or ATS facilities notifications to ATC may be completed any time during pre-flight operations. Within 30 minutes of the proposed departure time, an ATC connection established message will be received by the aircraft. During high congestion operations such as inclement weather, runway changes, or large pushes, the session establishment time may be shortened. Session establishment will occur automatically after the controller completes his or her tasks and the time parameters have been met. The logon will occur as long as the following conditions are met: the logon information was correctly formatted, an ATC flight plan is on file with indication that the aircraft is DCL capable, and ATC approved the DCL. If the initial attempt to log on fails, ensure that a flight plan is on file. Verify the logon information is correct, and attempt one additional logon. If the second logon attempt fails, revert to voice communication and contact clearance delivery. Follow your company policy in regards to the preferred method of data communication with ATC. Once a successful ATC connection has been established and the clearance has been approved by the controller, the DCL will automatically be sent to the aircraft. After the first received uplinked clearance, a subsequent DCL may be requested for your particular aircraft. This will result in either a full route clearance or a clearance to a specified position. When making a DCL request, do not add any free text to the downlink page. If any free text information is added, the ground system will reject the message and send an auto-reply message indicating "Not allowed." Any DCL message sent directly to the aircraft should be treated just like any voice or PDC per company procedures. An additional feature of the DCL service is the ability to introduce revisions to a cleared flight plan. Amendments can be a simple altitude change or a more complex full reroute. When notified of a revised clearance, flight crews should use good judgment and follow their company procedures in reviewing and responding in a timely manner. Revisions can be received at any time until the aircraft is handed off to the tower for takeoff. When an initial or revised DCL is received, act in accordance with company policy to review and either accept, reject, or use standby as appropriate. It is recommended that both crew members read each Cpdlc clearance and confer before maneuvering the aircraft to comply with the clearance. If a revised clearance is received off the gate, responses need to be made with more diligence than when at the gate. A revised clearance may contain simple changes, like an updated transponder code, or complex changes such as a full reroute. Complex revisions may require substantial heads down time for FMS route loading and verification. In some cases, it may not be prudent to conduct these activities when the aircraft is in motion. It is recommended that you notify the appropriate ATC facility and pull out of the ground traffic flow when required by company procedures, in areas of high traffic density or high tempo operations, in low visibility or night operations, or required for safety of operation. The load option is available when ATC route information is included in the Cpdlc uplink. Selecting load will transfer route information into the FMS route or secondary flight plan for review prior to acceptance. Remember, the departure and departure transition are not included in the loadable route uplink and must be manually entered into the FMS when provided in the DCL. When no changes have been made to the filed flight plan, ATC will send a then-as-filed departure clearance, which does not contain a loadable route clearance. In this instance, route information must be manually entered into the FMS. If ATC has modified the filed flight plan, an FMS loadable route clearance will be sent to the aircraft with either a cleared route clearance or cleared to position via route clearance message. Care should be taken in entering or requesting data after loading the uplinked DCL into the FMS. It is important to use the individual FMS pages to request AOC company wind, performance, and/or takeoff data, or manually enter the data per your company procedures. Additionally, using the following functions will delete the cleared ATC assigned route from the FMS and should not be used. For Boeing aircraft, AOC company FMS route page route request function. For Airbus aircraft, FMS initialization company flight plan request function. If the cleared route is modified after the original DCL has been accepted, ATC will send a revised DCL to the aircraft. Remember that departure procedures, transitions, and the departure runway are always manually entered by the flight crew. The route modification will have one of three types of loadable en route waypoint clearances: a change in the departure procedure and/or transition fix and route that connects downstream to the previously cleared route, a change to the clearance after the departure procedure transition fix or downstream of the first en route waypoint when there is no departure procedure contained in the cleared flight plan, or a complete route modification. Normally, an automated ATC-initiated disconnect can be expected within 5 to 10 minutes after takeoff. The disconnect time may be modified by local agreement for reasons such as local airspace requirements or flight crew's sterile cockpit periods to eliminate nuisance alerts. If the flight crew elects to disconnect their ATC Cpdlc connection or is terminated by the controller while on the ground, all subsequent departure clearance services with ATC clearance delivery will be handled via voice. Accepted DCLs will remain in effect for that flight unless amended by clearance delivery via voice. At any time, you can contact clearance delivery by voice to clarify the delivered clearance, to request an amendment, when requested by ground control, or whenever safety dictates. In this topic, we will demonstrate the logon process, session establishment, clearance requests, and Cpdlc message processing. The flight deck procedures are based on a Boeing aircraft model and assume the following. The aircraft is powered up. The IRUs are aligned. The flight plan has been filed for the aircraft tail number and flight ID. And the Airline Operations Center, or AOC, has preloaded the aircraft with the filed flight plan. In order to communicate with the tower using Datacom, a connection must be established. Logon can be initiated at any time during the pre-flight process. A session will not be established until at least 30 minutes prior to pushback and after the controller has reviewed the filed flight plan. In the Logon 2 field, enter the National Single Data Authority Logon ID, KUSA. Next, enter the entire flight number in the field indicated. This must be identical to the entire flight number filed on the flight plan. If the numbers do not match exactly, a failure to establish the session will result. If the field is not already populated, enter the tail number. Like the flight number, this must match the filed flight plan exactly. Most connection failures result from incorrectly entering either the flight number or tail number. Initiate the logon by selecting Send. The word Accepted appears. After the controller has processed your flight plan and moved it to the prepared list, the display should read ATC COM Established in the scratch pad. Finally, verify the ATC center. Once verified, logging on to a Datacom session is complete. In this section, we will describe how to request the departure clearance from the tower. To request the clearance, first select ATC Index. Next, select Clearance. Do not add any free text, as this will cause the system to reject the request. Select Send. Notice the status displays Open. An audio chime will be heard when a message is received. ATC message displays in the scratch pad. On some models, a message light on the MCDU illuminates when a message is received. There are only two possibilities when receiving an initial clearance: cleared as filed or revised initial clearance. Cleared as filed is the most common situation in a tower environment. First, review the message that is received by selecting Uplink. A cleared as filed message should include a SID or climb-out instructions, altitudes, a squawk code, and radio frequencies. View the entire message on the MCDU and verify the content matches your expectations. For a cleared as filed message with no altitude assigned, notice there is no option to reject the message. If, in the rare case you no longer want to fly the originally filed route, you will have to revert to voice to make your request. Once a cleared as filed message has been received, you will be able to reject any future revisions. To accept the cleared as filed message, select Accept. Add the SID and transition and select Execute on the MCDU. Clean up any discontinuities in the FMS route. Acceptance of the cleared as filed route is now complete. If the controller cannot provide cleared as filed, a revised initial clearance will be received. Select Uplink on the MCDU to receive the message. A new route or portion of the original requested route will be received, as well as a SID or climb-out instructions, altitude, squawk, and radio frequencies. To review the message, load the message and page through the clearance while observing the route specifics on the MCDU and nav display. If able to comply with the new clearance, select Send associated with Accept. If unable, select Reject. No reason code can be added to the rejection. If the clearance cannot be accepted, contact the controller by voice after sending the rejection. Once the clearance has been finalized, add the SID and transition and select Execute on the MCDU. Clean up any discontinuities in the FMS. Acceptance of the revised route is now complete. The last procedure we will cover is revising a clearance. Revising a clearance can be accomplished at the gate, in the movement area, or on taxiways. In this scenario, clearance has been received and accepted, and the aircraft is pushing back from the gate when the controller has to change the clearance. ATC message is displayed in the scratch pad and accompanied by the associated audio chime to alert the crew. Select ATC on the MCDU to read the clearance. This may include a whole new route, a portion of the route, a new SID, or even a non-route revision. Regardless of the type of revision sent, review of the new clearance in its entirety is required. To ease the workload, the revision will contain indications of what has changed. Load the new clearance and review it on the MCDU and nav display. If the route changed, a dotted white line indicates the new route, and a solid magenta line indicates the previous route. If able to comply with the new clearance, select Send associated with Accept. If unable to comply, select Reject. Once accepted, add the SID and transition and select Execute on the MCDU. Clean up any discontinuities in the FMS. The procedure is now complete. Departure clearances should be processed while at the gate or while the aircraft is stopped in the non-movement area. Ideally, the departure clearance would be entered and verified before pushback. Simple revisions of departure clearances, such as a change in squawk code, can be made while taxiing, but always use caution when the aircraft is in motion. To reduce the risk of runway incursions, significant heads-down activities should not be conducted while taxiing in close proximity to an active runway. As with other complex tasks, revised departure clearances that require substantial data entry, such as those involving a runway change, should be processed while the aircraft is stationary with the parking brake set. Cpdlc messages may be more than one page in length. Some implementations do not allow the pilot to respond until after the last page has been displayed. Therefore, care must be taken to ensure that the entire message is reviewed before a response is sent or an instruction is executed. An inquiry or an expect message from ATC should never be considered a clearance. For example, "When can you accept?" does not constitute a clearance. Similarly, a response to your message, "When can we expect?" does not constitute a clearance. Be aware that response times of Cpdlc communications can impact air traffic operations and efficiencies. For example, the use of standby is recommended whenever additional time is needed before a message response can be given. There will be times when a standby response will not be operationally appropriate and reversion voice communication becomes necessary. Dialogues initiated on the Cpdlc need to be finished on Cpdlc. The Cpdlc dialogue will need to be closed out with an accept or reject response, even if a verbal response has been given. Use standard messages from the message set whenever possible. Free text messages are to be used only when an appropriate standard message does not exist. When composing a free text message, standard phraseology and format should be used. All non-essential words and phrases should be avoided. Abbreviations should only be included in free text messages when they are part of standard ICAO phraseology. Printers may not produce an exact replica of the message on the flight deck display. For example, it can print pages out of order or fail to print the last page. Even if the message is printed, it must be reviewed on the display approved for that purpose, such as the MCDU or ACARS, before the message is used. Conditional clearances, such as those that instruct you to act at or by a particular time or position, require special attention. Operational experience has found that a common error is to miss the condition, such as the word "at", and climb or descend immediately rather than wait until the condition is satisfied. Therefore, it is recommended that each pilot perform the silent read, confer, and then execute procedure to help alleviate communication errors. An advantage of voice communications is that both pilots are able to hear ATC messages and then verify each heard the same thing. With Cpdlc, typically the pilot monitoring is responsible for managing data link communications. To maintain situational awareness, implementation of crew verification procedures in regards to datacom is wise. It is recommended that both the pilot flying and pilot monitoring silently read all ATC clearances and then discuss the message and response before executing the clearance. This procedure will help prevent expectation bias. That is, if the pilot monitoring reads the message aloud, the pilot flying would likely see the clearance that he or she just heard, making it difficult to detect a discrepancy. Follow your company's standard operating procedure in regards to communicating with ATC. During the en route phase of flight, Cpdlc can provide direct communications between the aircraft and air traffic control. This provides Air Traffic Services Facilities Notification, or AFN, Automatic Dependent Surveillance, or ADS, and Air Traffic Control Data Link messages. Once Logon is complete, data link messages can be sent from ATC to the airplane, and from the airplane to ATC. Transfer to the adjacent ATC facilities is automatic. Typically, for Cpdlc to be operational, the aircraft must have ACARS and SATCOM for operations beyond VHF coverage. Logon is completed using the ATC button on the CDU. When pressed, the first page displayed is the Logon status page. In this example, we will log on to Gander Oceanic Control for a flight across the North Atlantic Ocean. Logon should be accomplished with the appropriate ATC facility 15 minutes before entry into the Cpdlc ADS airspace. In this case, CZQX for Gander Oceanic is entered into the box prompts. Verify that the flight number and tail number are correct. Now, press the Logon Send prompt on one right. Once Logon is complete, ATC COM established is shown on the scratch pad. The Active Center displays the current ATC facility, and the ATC COM Select Off prompt is displayed, which, if selected, will terminate the data link connection. Page 2 controls the ADS status. The ADS system can be toggled on and off. The ADS emergency mode can be turned on and off. When a Cpdlc message is uplinked to the aircraft, the crew is notified by a chime and an ICAS message. Here's an example of an uplinked clearance to climb and maintain flight level 350 and to report level at flight level 350. Both crew members should silently read and consider all pages of the message individually, and then, after considering the content, either accept or reject the clearance. Let's accept the clearance. After pressing the Accept prompt, our response is transmitted to ATC. Notice that the Report ARM prompt is now available on the CDU. Cpdlc allows certain reports to be made automatically, in this case when we level at our assigned altitude. The prompt is selected, and the report is now armed. As the aircraft levels off at flight level 350, the report is automatically sent to ATC. As an alternative example, let's take the previous scenario and reject the clearance. To respond unable, the Reject prompt is selected, and we can choose a reason we are unable to climb. In our example, it is because the aircraft is too heavy, so due to performance is selected. Now the report can be verified and sent to ATC. If an uplink message contains data that can be loaded into the FMC, a load prompt is included. A good example of this would be a route change by ATC. The message contains the new route and the load prompt. After the clearance is accepted, pressing the load prompt inserts the new route into the FMS. The crew can then review and execute the new route. Uplinked and downlinked messages can be viewed at any time by selecting the log prompt on the ATC uplink page, or by selecting log from the ATC index. On the left side of the message, an arrow indicates if the message was uplinked from ATC or downlinked by the aircraft. Individual messages can be viewed by pressing their respective prompt on the right side of the CDU. You can see that the Level 350 report is included in the log. By selecting the message, you can see Level 350 and the message's status. The ATC index page can be thought of as a main menu and allows the crew to start their ATC communication. Many of the pilot downlinks begin with the request prompt. Changes to altitude, speed, offset, and route can be made. In general, the format for these requests are similar. For example, let's request a climb to flight level 370. Select altitude from the request page and enter flight level 370 into the altitude field at one left. In addition to the requested altitude, there are modifiers included on the page. These modifiers allow for additional requests or clarification from ATC. For a climb to reduce fuel consumption, due to performance can be selected. For a climb to establish a smoother ride, due to weather can be selected. Once the desired request is complete, select the Verify prompt to view the message. Once verified, the message can be sent by pressing the Send prompt at 5 right. The prompt then disappears and is replaced by the status of the message. Desired changes to routing can also be made from the request prompt. Direct routing to a fix, along with a specific heading or a specific ground track, can be entered and requested. Additionally, the Cpdlc system can communicate with aircraft's FMS system. Routes loaded into Route 1 or Route 2 of the FMS can be directly requested with these two prompts. When pressed, the loaded route is directly requested from ATC, significantly reducing the time and errors involved with writing the route as a free text message. Additionally, specific departure and arrivals can be entered and requested from the route request page. Previously, we discussed how leveling at an assigned altitude can be automatically reported. This report, along with additional ATC requested reports, can be accessed through either the report page or the ATC log. For example, ATC may wish to know when we can accept a higher altitude. In our case, we will say that we can accept flight level 390 at 1500 Zulu. Now the report can be verified and sent to ATC. The report will then be shown with a Sent status. As another example, ATC may want you to report back en route during a weather deviation. After the weather deviation is complete, the crew can select the Back en route prompt to notify ATC. Cpdlc can also be used for ATC position reporting. Typically, position reports are relayed automatically, but they may also be requested by ATC. Position reports are accessed by the Position Report prompt on the ATC index page. On this page, the last waypoint crossed is reported in the standard position reporting format. After the information is viewed and verified, pressing the ATC Send prompt at 6 right will send the report directly to ATC. If any ATC requests, reports, or questions don't have an appropriate field or additional information is required, the free text prompt can be used. This allows the pilot to simply type a message and send it to ATC. If voice communication is desired instead of Cpdlc messages, a revert to voice message can be sent using the voice prompt on the ATC index page. An emergency can be reported to ATC using the Cpdlc system. Once an emergency is declared, ATC can immediately determine the aircraft's position with ADS and can increase the amount of position reporting during the emergency. Selecting the emergency prompt on the ATC index allows the crew to fill out a template that gives ATC some basic information. Depending on the severity of the emergency, either a Mayday or PAN can be declared. The diversion airport, along with souls on board and fuel, can be stated. Any emergency route offset and descent altitude can be entered. After all information is entered, the report can be verified and sent. Once the Cpdlc emergency message is sent to ATC, the crew should expect an immediate acknowledgement by the most appropriate means, Cpdlc or voice. A Cpdlc acknowledgement will be sent as a free text message with the words Roger Mayday or Roger PAN. In addition to a Cpdlc acknowledgement, ATC may also attempt to make voice contact with the aircraft.
That is incorrect. That is correct. That is correct. That is incorrect. That is incorrect. That is correct. That is correct. That is incorrect. That is incorrect.